Hello guys, this is what I was talking about, the Aufbau Principle. It states that in the ground state of an atom or ion, electrons fill atomic orbitals of the lowest levels before occupying higher levels. Before we continue, what does that mean? I'm sure we've all learned that electrons, like in atoms, electrons are always found in energy levels called shells outside the nucleus. Yes. Now, what they didn't tell us, because I don't think it's at our level, but it's handy additional information, is that those shells have what we call subshells. There are 4 types of subshells. There's the S subshell, P subshell, D subshell, and the F subshell. Let's say, for example, the first shell, it only has 1 subshell. The second shell has 2 subshells. The third shell has 3 subshells. Okay, it will make sense when we try an example, but if you just talking, it's confusing. So each of them has a subshell, and there are specific subshells that get filled before they go to the next one. They fill the subshells with lower energy before they go to subshells with more energy required. The first subshell to always fill is S, then followed by P, then followed by D, then followed by F. That's where so let's look at this, for example. The first shell, which is the one here being denoted, only has 1 subshell. And the S subshell can only hold a maximum of 2 electrons. And that's where that principle for, I don't know if you remember, that the first shell of an electron always holds, the first shell of an atom always holds 2 electrons. That's where it comes from. Then let's say the second shell. The second shell, which is denoted by the 2 here, has 2 subshells, the S subshell and the P subshell. The S subshell, as stated there, can only hold the maximum of 2 electrons, and the P subshell can hold a maximum of 6 electrons. So in total, the second subshell can hold a maximum of 8 electrons, 2 plus 6. As we can remember, they told us the second shell holds 8 electrons, but they're divided into 2 subshells, one with 2, one with 6. Third shell, if you were to add this up, 2 plus 6 plus 10 gives you 18. I don't know if you remember that, but some of us were told that third shell actually holds a maximum of 18 electrons. It's just that you can't draw 18 electrons in your book with those Lewis diagrams, so they minimized it to 8 just for convention's sake. So this one just talks about, it brings into account all the subshells and how they actually get filled, which one is first, which one is last. That's what the Aufbau Principle is about. Let's give an example. We know the element sodium has an atomic number of 11, and we know atomic number is the number of protons, and number of protons is equal to the number of electrons in a stable atom. Yes. So the electronic configuration of sodium using the Aufbau principle would be as follows. 11 is the number of electrons we have. So the first shell to get filled is the 1s shell. The first shell only has 1 subshell, and that's the first thing to get filled. You can follow these arrows, and you get the hang of it with more practice. So if we fill the first shell, which only has 1 subshell with 2 electrons, like we do here, we are only left with 11 minus 2, we're left with 9, right? Yes. We go to the next one to get filled is the second shell, under which is the S subshell. So we fill that one as well with 2 electrons, as we've done here. And 9 minus 2, we're left with 7. Next subshell to get filled is the P subshell under the second shell, or just for convenience sake, I'm calling them subshells, but they are also called orbitals. That's the other name. So The next one to be, yes, what we're saying is, the next subshell or bit to be filled is the P subshell in the second shell, like second shell, and it has 6. So 7 minus 6, we're left with 1 electron which we haven't placed, and we've put that there. Next subshell to be filled is the S subshell under the third shell, which can hold a maximum of 2 electrons, which the 2 I've put there. But we don't have 2 electrons left, we only have 1. So we put the 1 left there, and that's our electronic configuration of sodium using the Aufbau principle. If you have any queries, you can ask again, but that's just like basic. Practice will make it. You get the hang of it if you practice.